Good afternoon, everybody. This is a defense in-depth approach to building web applications. My name is Maritza Mills. I'm a senior product manager with Amazon Web Services, and I have about 8 years of experience both building and supporting web applications.
My name is Paul Ormland. I'm a software development manager with the AWS WAF group within our perimeter protection organization. And I've got probably about 8 years or 9 years of both building and managing service teams that build cloud solutions.
Cool.
So take a second, kind of read through that. I like this quote because when I think about security and when I think about approaching security within our applications, this reminds me that we want to take a comprehensive approach. I like the word thorough in there. A lot of people think about security as a last-minute addition to their applications. You'll go ahead and write a bunch of code. You'll go stand everything up in AWS, and then you'll say, oh, I need to make it secure. But what we're going to talk about today is what a more in-depth understanding looks like.
So just to give you an overview of what to expect today, we're going to start by defining what we mean by a defense in-depth approach to security. Then we're going to dig into the details of building security in your application as you're architecting it. Then we'll discuss ways that you can build the security around the application itself. And then we're going to jump into some advanced mitigation strategies that are employed by customers on AWS today.
So when we decided to entitle this talk Defense in Depth, the thing we were thinking through was this old medieval strategy, right? Where when you think about defending something, if you've got one single point of failure where if an attacker is able to breach your defenses, they're either all in or all out, that's not very effective. So when we think about defense in depth, we want to basically spread out an attack over a large surface area, which allows us to slow down that attack, right? And then we can provide multiple specialized solutions to prevent that attack. And so what it really does is instead of trying to prevent an attack from happening, it makes the attack not worthwhile. So the attacker loses momentum as they try to attack your application. So we're going to kind of talk about 3 different ways that we provide a defense in depth within AWS. It's going to start with building on a secure platform. You're all here because you're interested or using AWS technologies, and we provide a lot of things out of the box that we'll get into in a little bit that will just help you just by building on top of AWS. Next, we're going to talk about building security within your application, right? There are things that you do as application developers in your code and in your architectures that are going to make you less vulnerable to being attacked. And then we're going to round it out with talking about how you build security around your architecture, right? Using some of the AWS technologies that we provide like Firewall Manager, Shield, and AWS WAF.
And so when we're talking about building multiple independent layers of security, one of the things we want you to keep in mind is the intrinsic multi-layered aspect of the web applications that you're building and how those layers relate to the different services that you use at AWS and how you can use those services as part of how you kind of build that security both in and around your application. So you see here, when we're talking about the application layer, there are things that you can use CloudFront for or Amazon Route 53 for as an aspect of building that security. And then we'll talk about things that specifically affect layers at layer 3 and layer 4 that might affect, say, your hosts on EC2. So for example, there are certain attacks that might happen at the outer layers of your application, such as the application layer, such as a SQL injection attack. And this type of attack, if you have any kind of data inputs that you're accepting from users or returning any kind of information to users from a database, if you're not properly sanitizing and validating what those SQL queries are, you could be giving data to people who shouldn't have that data. And we'll talk about ways to protect against that. Additionally, it could be something like bots, which may not even necessarily be malicious. It may not be that they're trying to access something that they shouldn't have access to. It could be a bot, say, that is just scraping news sites, to aggregate different news from different media websites. And if you don't handle that bot correctly, it could cause slowness in your application. As we move down the layers a little bit, you might have to think differently about different types of attacks that could be occurring. There could be different types of, say, denial of service attacks, such as a UDP flood or reflection attacks that could occur at these layers. And the reason we want to bring these to your attention is because security is not just about unauthorized access. Security is about making sure that your applications are up and available for authorized users when they need to access them. And so just to touch on the last two layers, these are operated and protected by AWS intrinsically. And the reason I want to point that out is because you may be familiar with the shared responsibility model that we have here at AWS. And what we mean by shared responsibility is that AWS provides and protects the foundational hardware, infrastructure, as well as software aspects that you're building your applications on. But it is your responsibility as the customer as to how you choose to architect your applications on AWS, as well as how you choose to expose those applications to the internet. So to get started, when we talk about the shared responsibility model, there are ways that we do make this easier for our customers to take on that responsibility. And one of the things that we do here at AWS is offer standard protections for every single customer who's operating internet-facing web applications on our platform. So for example, we have something called AWS Shield Standard, which protects from all the most common Layer 3 and Layer 4 DDoS attacks. For anyone who has an internet-facing web application. Additionally, if you want additional Layer 7 protections, you can use Amazon Route 53 and Amazon CloudFront and take advantage of those distributed POPs that we have located all over the world. So as an example of this, I wanted to talk about a customer that we have, which is Slack. Slack in particular was interested in accelerating their API and reducing the latency to access their API. As part of that as well, though, they had a need to make sure that they had some kind of inbuilt DDoS protection as well. And the reason I want to point this customer out is that they did choose to host their application on Amazon Route 53 with a CloudFront distribution and behind an application load balancer. And the reason I want to point this out is that without Slack having to do anything else at this moment, they are already protected against the most common DDoS attacks at Layer 3, 4, and 7. So next, let's talk about building security in your application.
So there's really two main aspects of a defense in depth strategy. And we're going to touch on this first one, which I've highlighted in the red box right now, which is hardening inside your application. So this is best practices within your architecture, as well as best practices within your code.
So when we talk about building the security in your application, there's a few things you need to think about before you even get started. So one thing is that you should first understand what you're trying to protect against. You don't want to be building generic security protections without really thinking specifically about how your application might be vulnerable. And then second, once you know what those are, then you're going to proactively architect and write your application in a way that prevents it from being exploited. And then lastly, once you've built your application, you do want to make sure that you have the right monitoring and other mechanisms in place to detect if there is a security event that you need to take action on or make an update to your application based on. And so one way to take advantage of the first one, which is knowing what those vulnerabilities are, is by looking at something called the OWASP Top 10. The OWASP Top 10 is from the Open Web Application Security Project, which is a not-for-profit research project that is contributed to by many different security experts and specialists, both in the private sector and in academia, who come together to make individuals aware of what are some of the most common vulnerabilities that are in web apps. So I touched on injection earlier. We'll have some examples about cross-site scripting. I don't want to go through all of these, but I do want you to take a look. Chances are, if you're operating some kind of internet-facing web app, one or all of these do affect you.
So let's dive into the injection example, right? So we're thinking about how are we building security within our application. This is before you're even building out on AWS. SQL injection is one of the top 10 vulnerabilities that OWASP has defined. And what I'm trying to do here is give you two different examples. One of vulnerable usage, where your application is not doing everything that it can to protect yourself against this attack. And another one where you're doing more, where you're able to protect yourself. So what we notice about the first one here is what we're doing is we're taking in these two parameters, the name and the ID. We're taking these as inputs from our customers or our users or whoever's coming to our site. But what we're doing is we're actually blindly putting those into a query that we're going to execute against our database. And the problem is there's no sanitation. So we don't know that an attacker isn't maliciously crafting those inputs such that the query that's executed against your database is not what you expected. So in the secure usage, we're actually doing the same things. We're taking in those same two parameters, but the difference here is we're relying on some of the framework technologies that we're building on. So in this case, the prepared statement object, right? Where we're taking those variables and we're setting them in to that, which is going to do validation on that. And so just taking advantage of some of the built-in technologies in whatever language, whatever frameworks that you're using to do things like sanitation and validation of inputs is the first step in protecting against an attack. So when we actually go and execute this query here, we're going to have some baseline level of protection that we wouldn't get if we just took it and concatenated a string together. The second one that we want to cover is cross-site scripting, or XSS, right here, right? So a lot of times when we're building our web applications, we think, oh, well, this is running, within my session, within a customer's browser. There's not really a lot that's going on. But what I want to kind of point out here is if you're referencing third-party libraries, you're using other people's code within your applications, part of what you may be opening yourself up to is a cross-site scripting attack. And so in this attack, what's happening is, we've included some JavaScript that's coming from some other site. What they're doing is they're crafting a URL that's actually going to take the cookie data from our site, things that might contain PII or other sensitive information that our customers don't want leaked, and it's going to actually send it when this image is loaded, right? Another one is a simple defacement of the website. So they're coming in and they're crafting this such that the website is not going to look and feel as though you intended it to. And so these are two common ways that we have to think about protecting our app when we're including other data within our applications. We'll get a little bit more into this later too. So when we think about cross-site scripting, there's three main areas I want you to think about. There's a lot of text on the screen here, but essentially what I'd like you to think about is the orange is how is the content that I'm displaying encoded, right, such that it's not significant to an interpreter, right? So if I'm including third-party content, am I encoding it correctly? This is, whether it's CSS or HTML that's coming from somewhere, so that when my application's interpreting it, it's not going to be significant if there's something bad in there. The purple or the middle one here is just the sanitation. And this is really just don't use stuff from third parties or even from second parties that you don't trust, right? Like understand what you're putting within your application. And the last one, the blue one, is thinking through a lot of the coding, right? So we want to do things like we want to sandbox where we can, meaning that we want to limit the execution within our websites to the smallest area possible there. We also want to think about what's going to happen with those objects. Is there going to be serialization? Is there going to be deserialization where there's going to be an interpreter going through some of this code that may inadvertently run malicious code on your site? And so thinking about how you can reduce those, the surface area of the actual code that's running, as well as the objects that are being used, and that the fact that they are likely going to be serialized and deserialized is important. So we had the OWASP top 10 attack vectors. There's also a recommendation on 10 things you should be thinking about as you're building your applications, right? And again, there's a lot of text on here. These slides are going to be available in the coming days. But what I highlighted is 4 things that I think you should be thinking about that are crucially important. First, define your security requirements, or understand what's normal for your application, because a lot of what security is about understanding and determining and detecting abnormality, right? And so you should first think about, what do you expect your application to do? What do you expect your users to be doing within your application? Second, as we kind of touched on in the last couple slides, validate all your inputs, right? Like, that's a huge way that you can help protect yourself, is making sure that you're not using malicious data in your application, whether it's a SQL query or some other mechanism. The next is implement some sort of logging and monitoring, right? What this is going to allow you to do is this is going to allow you to detect when something abnormal is happening, right? Within AWS, and we'll talk about this a little bit, we have things like CloudWatch, right, which allows us to see metrics on how our application is functioning, but also set up alerts and alarms when it is functioning in a way that we don't expect. And then the last one is just understanding what the known failure cases are within your application and handling those in a graceful way such that you reduce the surface area of something unexpected happening.
Okay, so that was building security in your application. Next, we're going to talk about how you can build security around the application itself.
So as I said, there's two real sides to this, right? So the first side we talked about was the things you can do inside your code. The second one, the last three bullet points here, are really how you can protect yourself around your code. So this is using things like identity and access management, right? Using security groups, having the right monitors and alarms set up on your application such that you can actually detect something that goes wrong, and having logging within your application such that when an attack happens, you can then go back and understand why, how, and update your either security policies or your application if there was some vulnerability within it. But you want to be thinking about this holistically. Again, it's not something that you're just going to put on the outer shell of your application. It's going to be at every step of the way as you're building your architecture.
And so when we talk about how to build this security around your application, we'll touch on a few tools that AWS provides as a way to help build that security around it itself. I touched earlier on the standard protections. So just by building on AWS, your internet-facing applications, again, are protected against the most common DDoS attacks at layers 3, 4, and 7. We'll also get into, however, some managed rules that you can take advantage of with AWS WAF. So if you're deploying a web application and you want to get started very quickly with security without having to write your own rules, managed rules are a great way to do that. For those of you who have more custom needs, you will be able to write custom rules with AWS WAF. Some of you may be doing that already. And then we'll talk about how you can scale the configuration of your security policies in AWS and how to audit those policies as well. So starting with managed rules, many of you may be familiar that in the AWS marketplace, we have a myriad of choices of different seller managed rules. Some of them, for example, are based on the OWASP top 10 that we talked about earlier. These rules are automatically updated by AWS sellers, so once you subscribe to them, there's not much else that you need to do other than to decide if you want to keep using them or take on more. In addition to that, just last week, we also launched AWS Managed Rules. AWS Managed Rules are similar in that you are not going to have to do any rules writing yourself. You're going to be able to take advantage of a lot of the threat intelligence that we have developed here at AWS by protecting our customers and protecting our own website. And what we've done is taken a lot of that information and put it into these managed rules so that you can have them as well for your own web applications. As a part of this update, both Seller and AWS managed rules are now available to choose within the console, and you can absolutely pick and combine them in any way that you choose. So as an example of that, here is a list of some of the AWS managed rules that we're making available. I'm not going to read through all of them. However, for example, let's say you wanted to quickly spin up a WordPress site that you're hosting on a Windows machine. One of the things that you might decide to do is say, I want to implement the following managed rules. I'll use the core rule set to protect from the OWASP top 10. I'll also choose the WordPress rule set that protects from WordPress specific vulnerabilities. And I'll also use the Windows rule set as well. And this lets you very quickly get started with a basic set of security that you can apply to your web application.
So one of the things that I love about what we just launched with the managed rules is we've got a team, a threat response team, that's actually analyzing and updating these rules on your behalf without you having to do anything. You'll get the latest updates. And I want to take a look at one specific one, which I think is going to be one of our more popular ones that folks use, which is our IP reputation. And so what we're doing is we've got multiple sources that we're using as an input, but what we're doing is we've got this threat analysis automation, which is going out and it's trying to identify bots and other forms of malicious IPs, things like open proxies and other things like that. And as it identifies it, we're storing it in our threat database, right? And so this is a continual thing that's running 24/7, and we're storing it there. And then we've got our threat response team who has built some automation for us, which is going, and as threats are added into that database, it's grabbing those threats out, it's pulling the IP reputation data, and it's updating that IP reputation WAF rule. So as a customer, if you've added that AWS managed rule to your firewall policy, as those get updated, you're automatically protected against those new IPs that are added to that reputation list.
So we talked a little bit about the managed rules, but some of you might choose to write some of your own custom rules. And we do have those available via the console and the API with AWS WAF. The way that those work specifically is that when you get a request in, you may choose to put a web application firewall in front of your application, whether it is in front of API Gateway, an Amazon CloudFront distribution, or say an application load balancer. When you write the rules, you will write them to look for certain conditions. So it could be that you want to do a source IP match or even a geo IP match. Or, for example, you might want to look at the size of the request and say, I expect the request to always be within a certain threshold as far as the size is concerned. What will happen is that when you have a match on that condition, you can choose to take a few different actions. You could choose to simply allow the traffic through. You could certainly choose to deny the traffic. Or if you're simply interested in just monitoring your application, which we highly recommend, monitoring is also available via just counting. And all of these metrics would be available in Amazon CloudWatch. For those of you who are already using custom rules with AWS WAF, just last week we also launched some updates to our API. As part of those updates, we have added some new detection capabilities. The condition logic now has updated OR logic that's been added. You'll also have the ability to do multiple transforms on the request itself before it even passes through the rules so that you can do more efficient rules writing. You have a new way to write rules, so you can use JSON format for document-based rule writing. And then lastly, you'll see that we have had the elimination of various service limits that you might have seen previously before the update. So for example, where you might have had a limit of strictly 10 rules per web ACL, that upper limit has been removed, and it's now based more on how complex your rule actually is.
So kind of diving deep into that new document-based API, we hear from customers all the time, and limits were one of those things that we heard. But the other thing that we heard was that for any update that they were making, it would take multiple calls to our API because you'd have to get a change token, you then have to make your change, then submit it. What we've done is we've simplified that process. And with our new document-based API, you can create a policy just by calling the create web ACL, or you can update it just by calling the update web ACL. So no more of this back and forth multiple API calls, and we're pretty excited about that. The one exception is we do still have IP sets and regex pattern sets separate because those tend to be updated on a different cadence than the other types of rules within your application. And so you can do those again with the same create or update calls. But if you want to update an IP set, a lot of customers, and we'll get into an example in a second, have automation where they're constantly monitoring for new IPs. You'll be able to use those APIs as well. And then, as Marisa was saying, we have a much more robust Boolean logic that's available. We've got a syntax, which we'll show you in a second here, that makes it a lot easier to identify when we want to say or, and, or not within our policies. And then multiple transformations. So things like HTML decoding, URL decoding, getting rid of white space. You can apply multiple transforms before WAF actually evaluates the policy, which makes it a little bit easier to write your rules if you know that everything's going to be, say, converted to lowercase ahead of time. And then the other thing that we're pretty excited about is we've got a variable CIDR range support for IP matching. So where you're only able to get /8, 16, or 32, you can now define anywhere from 1 to 32. So this is a good example of our new JSON document format and an OR statement. And so what I think you'll see as you look through this is it's a little bit easier to understand what's going on. So in this sense, I've got an OR statement that says, I want to match XSS on a query string, while prior to evaluating the rule, I want you to decode the URL and convert it to lowercase. And if there's a match there or a SQL match in the body, or a SQL injection match in the body after you've transformed using our HTML entity decode and our compressing white space transformations, this rule would match if either of those two statements is true.
So lastly, I just wanted to touch on the scaled configuration and audit capabilities that we provide. So what you can do is with tools like AWS Firewall Manager, for those of you who are managing tens or hundreds, in some cases thousands of accounts, mirrored also by tens and hundreds and thousands of VPCs, you can use AWS Firewall Manager to manage that in a central or distributed fashion. The way it works is that you can have an administrative account that is part of an AWS organization, and Firewall Manager will allow you to both monitor, audit, and enforce security policies from the administrative account down to the different child accounts that are underneath. And as recently as October, we integrated this capability with Amazon VPC security groups, and it was also already integrated with AWS WAF and AWS Shield Advanced. And I wanted to jump into an example with the Amazon VPC security groups. So when we think about your security groups, this is a simple example of, say, you have a policy in a master account that says I only want to allow HTTPS traffic on port 443 for my EC2 instances. In that case, you could have this policy in your master account where you have this one EC2 instance, and then you'll notice that underneath there are two child accounts. The second account has ELBs, and the third account has an EC2 instance of its own. And so what Firewall Manager would do is it will take a look at the policy that is in the master account, and if you have the auditing turned on, it will go to the other two accounts and say, okay, it looks like in my third account, I do have an EC2 instance, and the policy on that appears to differ from the policy that's in the master account. So in this case, the third account has an EC2 instance with a policy that says allow HTTP traffic on port 80. And so what Firewall Manager will do is alert you to the fact that that particular account is non-compliant with the policy in your master account.
So as we've kind of talked about, defense in depth is thinking about the platform that you're building on, how you're protecting yourself within your code, and then how you can protect yourself around your code, right, and around your architecture. And so we've got multiple integration points with our web application firewall. As Marisa was saying, you can apply a firewall policy with your CloudFront distribution, your API gateway, or your application load balancer. And you can also use multiple strategies. So if you think about the definition that we provided of defense in depth, right? You want to spread out your attack. You want to have more specific, more targeted preventions in there. You have the ability to do that with your WAF policies, whether it's using the AWS managed rules or the seller managed rules or custom rules that you're writing. You can write specific rules that target specific attacks to your application. A couple things to call out. Using firewall policies is not just for blocking things like SQL injection or cross-site scripting. People can also use them for things like geofencing their application, right? If you only want your application accessible in a certain area, or you only want it accessible or you want it accessible by everybody outside of that area, you can use your firewall policy for that as well.
And so we can take a look at an example of a customer who did something very similar to that. In this particular example, we have a customer, Pearson. They actually used a multi-layered security approach with CloudFront and WAF as a way to secure against and mitigate against DDoS attacks. So on the one hand, they did use CloudFront to aid with their scaling. And similar to what Paul just mentioned, they did use the geography of the globally distributed geography of CloudFront in addition to policies that let them block by geolocation so that they could make sure that they were mitigating or limiting traffic to just the geolocation where the application was hosted. In addition to that, they also used a WAF to rate limit the HTTP requests themselves. And so we're going to go over an example here that is very similar to something that they did.
Yeah, so when we think about a multi-layer strategy, this is, I think, your basic use case, right? So we've talked about everybody kind of gets Shield out of the box, Shield standard out of the box. A lot of folks are using Route 53 to do DNS resolution and do routing towards your applications. But in this example, what we're going to do is we're actually going to use two different sets of firewall policies. Our first one's going to be set out at the edge at either our CloudFront distribution or our API gateway, and we're going to protect against common things. Maybe we're going to use some rate-based rules in here, or we're going to use our IP reputation, things that are generic to all of the applications within our stack. And then as we dive in to our actual stack here, we're going to have a WAF that's associated with our load balancer that's going to have custom rules associated with it. So what would that look like in practice? Well, let's say maybe we have two different stacks or two different applications. One's a Linux-based application using our, your usual standard LAMP stack, the Linux, Apache, MySQL, PHP. And then our other one is a Windows stack, right, using Windows, IIS, SQL Server, and ASP. So at the outer edge, both of those stacks are fronted by CloudFront. And so what we're going to do is we're going to apply our core rule set there. We're going to apply the AWS managed rule for IP reputation and SQL injection, because both of these are using some sort of SQL under the covers, right, within the stack. And so that's kind of our generic generalized protections, right, that we're providing all of the applications within our stack. But then as we get into this Linux application, we've got custom firewall policy rules that we're writing that are specific to our application. You know your application best. Again, as we think about defining what's normal, you're going to have rules that somebody that doesn't know your application wouldn't know to write. But we're also going to couple that with our PHP rules and our Linux rules, because we don't want to have to think about how do we write rules specific to PHP, or what are the common Linux vulnerabilities that we need to protect against. AWS is going to do that for you with our AWS managed rules. And then as we get into our Windows stack here, we're going to, again, have some custom rules that are very specific to our Windows application, right? To the way that maybe it's the types of inputs or the types of headers that you expect for this application. And then we're also going to use our AWS managed rules for Windows here. So we'll give you another, this is a very simple use case for AWS WAF, but we'll give you another one where maybe you have two different aspects of your application. You have one that's a public aspect where you want all of your customers or your clients to be able to use, and that's what we're defining here as the public internet. But maybe within our application, we actually have an administrative suite, something that we only want folks within our group that, in this example, are Seattle admins, right? And we only want them to be able to access that portion of our site. So what we're going to do is we're going to write a custom rule that will restrict that admin page to the three IP ranges that we've defined here, which we know are our Seattle-based IP addresses. And we're going to apply that to say that whenever the rule is matching our admin login page, and we're going to go ahead and convert that to lowercase ahead of time, because we don't want to have to think about case sensitivity or fat fingering something as we define that rule. And so what that's going to allow us to do is say that we only want to allow those IP addresses to hit that portion of our site, which will, again, restrict access to everybody else. So the last part of kind of that holistic approach I was talking about was also, so you have your code protected, you're using the right services, you've got firewall policies, and maybe you're using Firewall Manager because you've got multiple accounts or multiple things that you want to keep in compliance or audit. The other thing that you want to be able to do is, if something does happen, you want to be able to detect it, and you want to be able to triage it and debug it, right? And so the two things that we integrate within the AWS WAF product is Kinesis Firehose, which allows you to take on a per request basis and get full logs for your application. So as a request comes in, we'll send it to Firehose, and Firehose will send it to a destination that you want, something such as S3, perhaps. And that'll allow you, as you want to dig into the details and understand why a particular request came through or why a particular request was blocked, it gives you the data necessary to dig into those details. And then CloudWatch, as we've mentioned earlier, gives you the ability to monitor and alarm on the usage of your application, right? So you can go in and determine what's normal, what's outside of the bounds of normalcy for your application, and get an alert, right? Maybe it's something that's trivial. You have the logs that you can go in and check and analyze that, but you have the protections of knowing when something happens that you will get alerted.
Okay, so now we know how to build security in your application. We've talked about how to build it around your application. We'll take a little bit deeper look at some additional mitigation strategies that you can use to protect your app. So one customer example that we want to focus on is a retailer, evitamins, which sells vitamins directly to consumers. They had some concerns about malicious bots accessing their website. So they implemented their own what's called a honeypot strategy. That honeypot is designed to lure and attract bad bots, specifically so that they can be identified. And then their source IPs were added to a blacklist automatically. So when we talk about the honeypot, just kind of at a basic level, what you want to do specifically in, say, this scenario is you're going to want an IP set which contains the list of blocked IPs. You're also going to want a rule that you store in a WebACL that decides whether or not to allow something or block something based on the IPs that are in the IP set. And then lastly, what makes the honeypot what it is having that mechanism to detect and attract those bad bots, as well as the automated mechanism to add those source IPs to a blacklist automatically. And so if you take a look here, in this case, if you have a retail website, as I mentioned earlier, there could be malicious bots, but there could also be good bots. So what you're going to want to do is something like create a file, say it's robots.txt. And in this particular file, you might just want to say, these are the parts of my website that are not allowed to be scraped. These other parts of my website, those are fine. So a good bot is generally going to obey what is in your robots.txt. A bad bot, on the other hand, is not interested in doing that. So what you're going to do is you are going to also include a link on your website that is hidden. It's not a page that any of your users would ever see or even be able to direct themselves to. It is something, however, that is going to be attractive to the bad bot. And what will happen is that when the bot sees this link and it tries to follow it, you will have a script that automatically triggers and says, okay, I recognize that you are a bad bot. I need to know what the source IP of this request is. And then you will have the mechanism to automatically update your IP set, say in AWS WAF or in your WebACL, to automatically block any subsequent visits from this source IP in the future. And so this is an example, one example of a basic honeypot strategy. We have another customer, the Pokemon company, who also had some concerns of their own with bad bots. In their particular case, they were trying to secure their worldwide authentication service. And so they implemented their own version of the honeypot strategy.
Yeah, and so their strategy was pretty interesting. They started with AWS WAF in front of their application, right? But they took that data like we were talking about and they sent it through Kinesis Firehose. And then they pipe that into Kinesis Data Analytics. And what that's going to do is it's going to take that raw data and turn it into time series data. And that's going to allow them to analyze the rate at which certain IPs are trying to hit their site. They put a Lambda in between, which is actually going to do that analysis, right? It's going to look and say, you know, this IP over this range, right? was in there, and it's just going to store that data in Dynamo. It's going to queue up a message to either block an IP with a set TTL in there, and then the AWS update WAF Lambda is going to be listening for those messages. When it sees, oh, hey, this new IP needs to be blocked, I'm going to go ahead and update the WAF policy to block those. But there's also this other Lambda that's kind of running asynchronously to this, which is constantly going through and evaluating the TTLs for those IPs that are blocked, and actually creating an event or a message that says to remove them from the block list once that TTL has expired, and then it just dumps that message right back on the queue. And all of this is automated, so you don't have somebody that's sitting there having to monitor this, but you do have a pretty robust system that is able to identify bad IPs on the fly and update your WAF policies to protect against them.
And so that might be a theme that you've noticed with the last two honeypot strategies, which is a theme of automating your security. So we talked about managed rules, we talked about custom rules, but also a big aspect of staying secure and kind of scaling quickly with your applications and being able to react quickly to events is implementing automatic things like automatic detection or automatic controls. Or even automatic alerts so that you can immediately know when something has happened. We're going to look at a final example using Amazon Guard Duty for the detection, AWS Lambda for the automation, AWS WAF as part of the firewalling rules, and Amazon DynamoDB. So in this particular example, we're going to automatically block suspicious hosts based on finding types from Amazon Guard Duty. If you're not already familiar with Guard Duty is a service at AWS that constantly monitors your application and other aspects of your applications on AWS to look for things that might be anomalous or certain activities that could be suspect, and it returns those to you in the form of finding types. Let's say in this case there's a brute force attempt against or by an EC2 host. That might trigger, that finding type might trigger an event in CloudWatch. And what you can do is have that event also trigger a Lambda. So when that CloudWatch event goes off, that Lambda can do one of four things, or well, all four things. The first thing it's going to do is check Amazon DynamoDB, which has state data for the blocked host. And that's where it's going to grab the source IP from. Then what it's going to do is it's going to add that IP both to WAF as a rule and to your web ACL so that it can be blocked. And then it's going to use the Amazon Simple Notification Service to send you an email to alert you not only that a finding type has happened, but also to let you know that it's already been taken care of and you've already made a block based on that. And certainly you as the security administrator can go in and ensure that you did want to take that action. And so that was kind of a review of the different ways that you could automate your security, some advanced mitigation strategies. Certainly we're one of the first talks this week. If you're interested in learning more about that security automation, or if you're really interested in bot mitigation strategies, there's a number of different talks that are happening later today and later this week. I encourage you to look them up in your schedule. But for example, if bots are a big concern for you, we've got a talk, bot mitigation at the edge, that you could take a look at. If you have been kind of scratching your head about how to deal with your hundreds or thousands of security groups on Amazon that you have to manage, we also have a session on scaling security group management with AWS Firewall Manager. So definitely encourage you to take a look at these if you want to dive deeper. I think just to review what we've talked about today, to start, we talk about if you want a defense in-depth approach, you start by how you architect the application itself. So that's building security in your application. And then once your application is up and running, you want to make sure that you have security actually around the application itself. And then foundational to that is making sure that you are building on a secure platform in the first place, which we talked about the shared responsibility model and how AWS provides that security for you. And so this is the last slide. Again, if you want to learn more, we have AWS training and certification. But I think that is it at this time. If you have any questions, Paul and I will take them out in the hallway. So thank you for coming. Thanks.